over 1. Let's quickly work on this problem. Yeah, and this may be the last problem. It's still binomial theorem. I'm truly tired now. Okay, now find n or the value of n and a if the first three terms of the expansion of 1 plus ax to the power n of 1 plus ax all raised to power n in ascending order in ascending powers of x are 1 plus 12x plus 64x. So this means that 1 plus ax all raised to n is the same as 1 plus 12x plus 64x cubed. This is what we are told. This is given. There is no way that we can go against it. It's something that we are told that is okay. This has to be equal to this, regardless of how we feel about that. I'm sorry, this is not cubed, it's squared. It has to be square. Then 1 plus ax to the power n. According to what we know, this is equal to 1 plus nax plus n into n minus 1 all divided by 2 factorial plus n into n minus 1 n minus 2 all divided by 3 factorial x cubed plus dot dot dot. Lento into from the binomial expansion, the binomial series theorem. This is what we are being told. So now what we should do, our job here is to find the value of a and the value of n. So how do we do that? This is how we are supposed to do that. Please, when you write this, do reference that this is according to the binomial series theorem or expansion. Okay, now, so if this is equal to the, if this is equal to this, then this is equal to this. If left hand side is equal to this, then right hand side has to be equal to other right hand side. So 1 is equal to 1. 12x has to be equal to nax. 12x is equal to nax. Then dividing by x on both sides, we get 12 is equal to na, right? Dividing by n on both sides, then we get 12n divided by n equals to a. 12 divided by n equals to a. Let's call this equation 1. Then now let's consider this term with x squared and this term with this is a, this is ax. So suppose here I have ax squared plus, then also here I'm supposed to have ax cubed. So let's consider this term with x squared. Then say, okay, 64x squared has to be equal to n into n minus 1 all divided by 2 factorial ax squared, right? But ax squared is the same as a squared times x squared, laws of exponents. Then divide by x on both sides, then you get 64 equals to n into n minus 1 all divided by, times a squared all divided by bani, all divided by 2 times 1, which is 2 factorial. Now multiply by 2 on both sides. Multiply by 2 on both sides. Then you get 64 we get 64 times 2, 64 times 2, 60 times 2, that's 120. And then 2 times 4, that's 8. So suppose this is equal to 128. Let's double check. 64 times 2, it's 128, yes. 128 equal to n into n minus 1 a squared, right? Then now let's call this our equation 2. Now we have equation 1 and equation 2, and we have two variables. That means we simply need to solve those two variables, a and n, simultaneously. So let's say, okay, now why don't we substitute equation 1 into 2. Okay, now let's substitute equation 1. Let's substitute equation 1 into equation 2. This is equation 1, this is equation 2, so I have 128 equal to n times n minus 1 times, now in the place of a, I will substitute 12 divided by n, 12 over n, but because a is raised to some power 2, then that means I have to also raise this to some power 2. So 128 is equal to n times n minus 1 times. So remember that a to the power n over b to the power n is the same as a over b all raised to n. So this is the same as 144. 12 squared is 144, all divided by n squared, right? Because you guys are calculus students, I don't think you don't know that how to multiply fractions, divide, and all that. So I'll just assume that you guys know that. 128. Then now I have this n, I have n squared, so I have n divided by n squared, which is the same as n to the that, which is the same as n to the that, which is equal to 1 over n. So this will disappear. Then here I'll subtract 1, so I'll have n minus 1. I'll have n minus 1 times 144 all divided by n, right? Then I'll multiply by n, or I'll cross multiply here. Then I have 128n equal to n minus 1 times 144, right? And then now from here I will simply divide by 144 on both sides. Divide by 144 on both sides. I'm sorry, this whiteboard of mine is too small, so I cannot write each and every step. Make sure ba umamela yonke nendithethayo. So I will have this and that out. Then I'll have n minus 1. Then on this side I'll have 128 over 144 n, right? Okay, sure. Then now let's subtract n on both sides. Let's take n to the other side. But firstly, we need to know what is 128. What is 128 over 144? It's 8 over 9. Then here I'll have 8 over 9 n minus n equals to minus 1, which is the same as 8. Okay, which is the same as negative. It has to be negative 1 over, this has to be negative 1 over 9 n equals to negative 1. Then now let me carry on with this. Let me carry on with this right here. Let me carry on here. Hopefully it's still clear. Okay, so I have now -1/9n equals to -1, dividing or multiplying both sides. Dividing by -1 on both sides, then I get 1/9n equals to 1, right? Then I multiply by 9 on both sides. Then this and that goes out. Then n is equal to, now I know that n is equal to 9. I'm sorry. So if n is equals to 9, now solve for a now from equation 1. Then remember that a was equal to 12/n. So a is equal to 12/9. That means a is equal to 3 times 4/3 times 3. This and that goes out. So a is equal to 4/3. Then these are the values of a and n, but we need to make sure that these values are 100% correct. So let's double check. Okay, do that on your own. Take this 4/3, substitute it here, then take this 9, substitute it there in the place of n. You are supposed to get these same numbers, and trust me, you will get them. Trust me, you will get them. This and that. Thank you very much. That was it for today for binomial theorem. If possible, we'll also get to the absolute values. Thank you very much.